In this lecture, we're going to do an exercise. And what we're going to do is set up a subscript operator for a collection type that we're going to set up on our own. The class we're going to be using is the scores class, as you see here. It's just going to be wrapping around an array of double. The array is going to have 20 elements. It's going to be initialized to have zeros inside. This is how we can do this. And what I want you to do is to set up a subscript operator to be able to read and modify the data we have in this array using these operators here. You're going to see that all these subscript operators are going to be returning by reference. I want you to set these up in your own program, and you're going to use them to either read or modify data in scores object that you can create in your main function. On top here, you see that we have a few constructors. The default constructor is deleted because it's really not needed. It's not going to do anything useful. But a useful constructor we can use is to set up the data that we're going to be using to initialize our array here. And we're just going to be taking one parameter for the course name. Let's suppose that these are the scores for a given course in a classroom. And we're going to specify the course name, and then we're going to have the data stored in this array here. We're going to have the ability to modify the data through a subscript operator, and we're going to have the ability to read from the scores object using subscript operators. Another thing you should really be careful about is making sure that your type works either for const or not const objects, and you have to make sure these subscripts work here. This is a hint. We're going to have to do const overloading. We're basically going to set up a non-const and const version of our subscript operator, and this is basically going to allow us to do what we see here. We're going to be able to create score objects like we do here for the math scores. We're going to be able to print information. Printful is another function I want you to set up. You're going to make it loop through the array and print each element in the array. I hope you can do this. And then we're going to be able to use our subscript operator to change data in our scores object. For example, the element at index 5 is going to be changed to 88.3 here. And if we print the information again, we're going to see the change here applied. Another thing you should really be careful about is to make the syntax here work. Notice that this is a const object. So we should be able to use our subscript operator like this and print whatever data we have at index 5 in our array. Again, take a good look at our class here. You're going to set up this yourself, and you're going to make sure what we have here really works. You're going to set up the subscript operators to make the syntax here work. You're also going to set up a printful function, which is going to print all the information we have in our array. So give it a try and see if you can get this to work. If you have any problem, don't hesitate to come back and see how I do this. For now, I'm just going to head over to Visual Studio Code and get this thing to work. So here we are in our working folder. The current project is subscript operator for collection types. We're going to set up our template project. Let's copy this and we're going to put these files in. Let's do this. 35.6, that's our project here. And we're going to drag and drop this and open this up in Visual Studio Code. This is going to give us a starter main CPP file. We're going to clean this up and remove whatever we don't need. And we're going to set up our scores class. So let's do this. We're going to put in our scores header file and put this in. And we're going to put in a scores.cpp file. The first thing we want to do in the header file is put in our include guards. And the way to do this, if you don't remember this, you can pick into the autocomplete we have here in Visual Studio Code. We're going to say if not defined scores. We're going to use this name here. We're going to define this. And down here, we're going to go to the end and end our include guards here using an end if thing here. And we're going to say that this is going to end scores. Inside here, we're going to declare our class, which is going to be scores. So let's do this. We're going to say class, and we're going to say scores, and we're going to put this in. We're going to put in a private section, And we're going to put in a public section on top. This is how I like to do this. And our private section is going to basically have a string member variable, which is going to be the name for the class where these scores apply. So we're going to include std string to be able to use this. And after this, we're going to also include iostream because we're going to be printing some things in our printful function. Our member variables are going to be an std string type, and that's going to be our course name. Let's say std string properly. And it's going to be mCourse name. And we're going to have an array of doubles. It's going to be called mScores. And we're going to have 20 elements in. Not more, not less. We're going to have 20 elements in. And we're going to initialize all of these elements to 0 using a braced initializer here. If you wanted, you could put in a 7, for example, and all your elements would be 7, but we're just going to use 0 here, the default for braced initialization. Once we have this in, we're going to set up a few constructors. So let's do this. We're going to set up a default constructor, which is going to be deleted because we don't want people to be able to call this. We're also going to set up another constructor, which is going to take an std string parameter. And we're going to say const std string. We're going to take this by reference, and it's going to be course name. And we're going to put in an initializer list, which is going to pass this data to our mCourse name member variable. So let's do this. And we're going to use a braced initialization here. And we're going to say course name. This is going to do. And we're going to put in our body, which is going to be empty. And this is going to do for our constructors. And one thing we don't want to forget is to put the semicolon here. You see that Visual Studio Code is complaining about that here. So let's put this in place and make sure that this is working as we expect. What is the problem here? Okay, so let's ignore this and we're going to try and see if okay, so now Visual Studio Code is picking this up and the error and the squiggly line are going away. The other thing we want to do is to put in a function which is going to print information about our scores. So let's do this. It's not going to return anything, and it's going to be called printful, as we have been doing all along. And it's going to be a const member function because we don't expect this to modify anything about our class here. It's not going to modify any of the member variables, so it should be const really. So what we're going to do, we're going to say stdc out. We're going to say the course name. I think this is logical to do. So we're going to say mCourse name here. And then we're going to print all the elements we have inside. We're not going to put any new line character here. We're just going to put a semicolon. And then we're going to loop around. We're going to say for size t I, and we're going to initialize this to 0, and we're going to keep looping as long as I is less than 20 because we have 20 elements in this array. And we're going to put in our incrementation part. We're going to increment I, and we are going to hop over in the body of our loop, and all we have to do inside here is stdc out and say mScores and print whatever element we have at a given index here, and this is going to do. And I think it should be better to put an opening square bracket when we start printing stuff here. And then when we are done, we're going to put in a closing square bracket. And then we're going to put an stdendl here at the end of this. I think this is going to be better in printing our information. And at this point, we should be able to go to the main CPP file and include our scores header. So we're going to include scores.h, and we should be able to come down here and say scores, for example, and say math, and say the name for the course to be math. This is going to do. And if we come down and say math, printful, this should work. We're going to try and build this and test this step by step as we go to make sure it is really working as we want. And this is going to allow us to fix problems as they come up. And you see here, we are printing our data, but we don't have any spaces inside. And this is something we can fix now. And one thing you should also try out is to put in different pieces of data. Let's initialize our data to 85.6, for example. And then we're going to go on top here and separate these things with spaces. So for example, we can put a space after this. I think this is going to do. We're going to try and build this. And then the build is going to be good. We're going to clear and run rooster. Now we're going to see that the piece of data we put here is not going to initialize all the elements to 85.6. This is just going to initialize the first element, and all the other elements are going to be 0. And this is really interesting. Okay, so this is working. Let's turn this back to 0 because 0 is a really good default for these kinds of things. Let's build again. And we're going to clear and run rooster, and we're going to have 20 zeros printed out. If you count, you're going to get 20 zeros. And this is really good. Now that we have this, it is really working well. We want to set up our subscript operators and allow them to read the data we have in our scores array. They are also going to be able to modify the data. And we have seen the syntax to do that in our slides earlier. Let's clean up all these spaces because we want this to be really neat. And we're going to go on top here and set up our operator. The operator is going to return double, and it's going to return a reference to the data we have in our array. It's going to be a subscript operator. So we're going to say operator subscript, and we're going to give it the parameter as a size t type, and it's going to say index here. We're going to hop over in our function, and we are not going to do anything complicated. We're just going to return m scores, and we're going to return the element at the given index. We can do this. But remember that we only have 20 elements, and we really want to protect from using invalid indexes because that would be bad. So we saw a fix we could use to protect against this, and we're going to include cassert to do that. And inside here, we're going to assert and see that the index is really between 0 and 19 because these are the indexes we support in our array here. So we're going to say assert, and we're going to assert that index is greater than 0 and index is going to be less than 20. That's what we want. So we're going to say and index is less than 20. I think this is going to do. This is going to give us what we want. And it's going to force us to use indexes that are between 0 and 19. So let's say greater or equal because we also want to have 0 included. And this is going to allow us to go from 0 all the way to 19. And the 20 is not going to be included in here. So once we have this, we're going to be able to go in the main function and say math and use the subscript operator and say, for example, the element at index 5, we're going to change this to be 66.4. Why not? And after this, we can print our information. So we can go down and say math and printful. This should give us the change data. So let's build and run this. We're going to build with GCC and see that the build is good. The build is finished successfully, so we can try and run this, and you're going to see that the element at index 5 has changed to 66.4. So we can try and do something really interesting. For example, we can loop around. So we can say, for example, for size t, I, and I is going to be initialized to 0. We're going to keep going as long as I is less than 20. This is something you already know, and we're going to put in our incrementation part. And then we're going to hop over in the body, and we're going to say the element at a given index is going to be initialized to what we have in front of it, adding something. So in here, we're going to say if I is equal to 0, starting from the index 0, we're going to change this. So at index 0, we're going to say math 0. Equals, for example, let's put in 73.7. Why not? This is going to do. And else, we're going to change the value to an operation we do based on what we have in front of the index here. So, for example, we're going to say math I equals math I minus 1. And we're going to add something. Let's say we want to add 0.56, for example. Let's see if we can do this, and let's see what we get. We're going to take out the statement we did on top here because it's going to be really useless. And we're going to be changing the information using our subscript operator, and we want to change the information throughout the entire scores type. So we're going to change the first index to 73.7, and every other thing is going to be changed based on what is in front of it. So if we hit index 1, we're going to change that to whatever is in index 0, adding this thing, and we're going to keep adding until we hit the end of the program, and this is going to work really well. So let's try and build so that you can see the output from this program. The build is good. We can clear and run Rooster. And now you're going to see that we have some interesting data in our program, and it is going from 73.7, which is what we have here, and it's going to keep adding 0.56 until we hit the end, and we're going to get 84.35. And this is something you can do, and this is really cool. So our scores type is working as we expect. The second thing we want to do is to make it work with const objects. And if we try and set up a const scores object, we're going to have a problem here. So let's try and do that, and we're going to comment out what we have on top because it is working already. We don't want to worry about this anymore. So we're going to make this a const object, and this is not going to give you any problem. Let's change this to geography just to have something different from what we have on top. And the problem is going to come the moment we try to use our subscript operator. So for example, if we try to print out the element at index 5, let's say math, let's say geo here on top, and we're going to say geo at index 5. Let's do this. And if we try and use our subscript operator and print the element at index 5, we're going to get a problem. This is going to give us a squiggly line even from Visual Studio Code. If we hover over this, we're going to say no operator subscript matches these operands, and operands type are const. So the problem here is that our function here is not a const member function. And because it is not a const member function, it has the potential to modify our object, which is a const object, and the compiler is going to stop us from doing something like this. So we have touched on this problem in a few previous chapters we have done on classes and objects. And what we need to do to solve this problem and make this work on const objects is to do const overloading on our subscript operator here. And all we really have to do is to change it to be a const member function. And this is going to be overloading on what we have on top here. We're going to make it a const member function. And we're not really going to be returning a reference because the reference could be used to modify our array here. We're just going to return by value. And this is going to make our compiler happy. Now, if we do this, we're going to be able to call this function on const objects, and it's just going to get the value and print that out. And you see that the squiggly line just went away. And if we try and build this program, the build is going to be good. We're going to clear and run Rooster, and we're going to be able to print whatever we have at index 5 in our geo object here. And this is really cool. Because this is a const object, if we try and modify through the subscript operator, that's not going to work even because we are returning by value here. If we try to do this, we're going to get a compiler error. Because we can't really write into a returned value, that's going to give us a compiler error. Let me show you this. We're going to say geo, and we're going to use whatever index we want. Let's use a 4, and we're going to try and change the value to 55.8. If we do this, you see that we get a compiler error, we get a squiggly line. If we pass this through the GCC compiler, we're going to get a compiler error, and we're going to get an error that basically says we can't write into something that was returned by a value. This is all I can tell you by now. We're going to have more information on this early value thing later when we learn about move semantics. But for now, note that we are protected from modifying our const object through our subscript operator. But we don't really want to modify through this, and we just want the subscript operator to work to read data from our const object And this is working really well. If we build again, let's make sure this is working just fine. The build is good. We can clear and run Rooster. And this is what we want here. This is what we set out to do in this lecture. So this is really all I had to show you in this lecture. We have our scores class. It is wrapping over the double array. We have our printful function. We have our operators, and they are working really well. Another thing I want to show you is that you can move the implementations for these in the CPP file if you happen to want that. Let's comment these out and leave in the headers for these. And we can put the signature for the non-const subscript operator. And we're going to put the header for the const version of this. And we're going to move this code in the implementation file. So let's move this to the CPP file, which is really doing nothing as of now. We're going to include our header, scores, and we're going to go down and put in our implementations. Let's align this properly a little bit. And we have to say that these member functions belong to the scores class. So let's say that we're going to say scores, colon, this is going to do, and we're going to say scores, colon here. And now this is going to take out the squiggly lines. Another thing we have to do now, because the asserts are really used in the implementation file, we can take the include we did in our header file and move that in the implementation file, because that's where this is going to be needed. And now if we try to build again, we should see that the build is good. And this is what we see here. We can clear and run Rooster. And our program is going to run as it did before, but now we have our implementation set up in the implementation file, and this may come in handy depending on whatever you are doing with your C++ program. And let's go back to the main CPP file and make sure that whatever we did before, our const object is working, and we can come down here and put in a simple separator. We can do this just to make this easy to follow on the console when we run this program. And we're going to build again. The build is good, so we can clear and run Rooster, and we're going to get our data here, and this is really cool. This is really all we set out to do in this lecture. I hope you found it interesting. If you have any problem, please do ask. I will do the best I can to help out. For now, we're going to stop here, and in the next lecture, we're going to learn about stream insertion operators, and we're going to be able to print our objects directly on the console. And this is going to be really cool. So go ahead and finish up here and meet me there.